So hi everybody. This time we'll be working on our next lesson, and that is going to be about patterns and non-linear functions. So to identify, our goal is to identify and represent patterns that describe linear functions and also non-linear functions. All right. So let's have some definitions first, okay? When we talk about a linear function, we have already discussed before that this is a special function that if you graph it, it will be a non-vertical line, okay? So it could be slanted, it could be horizontal, as long as it is not vertical. Okay, so when you have a linear function, it could look any of this. Okay, so like I said, slanted, horizontal, as you can see, several dots over here, but they are perfectly aligned together, so that's a linear function. So if we have non-linear functions, so not line, all right, so these functions have graphs that is not a line or not a part of a line. So you can possibly have curves like this. So this is your parabola. Another curve here. This is your absolute value graph. So as you can see, it's not one straight line. Okay. So let's work on some examples here on how we can classify a certain data set or a table of values, whether they are linear or nonlinear. So in this case, the area in square inches of a pizza is a function of its radius r. So according here, okay? The cost in dollars of the sauce for a pizza is a function of the weight in ounces of the sauce used, okay? So what we need to do here is we need to graph these functions using this table of values here, and we have to identify which of them is a linear function and which of them is a non-linear function. Okay, so the problem already tells us what to do. We need to graph, and so this means that we need to use our graphing calculator, and that is Desmos. All right. Okay, so I just have my screen set up in such a way that we can see the problem or the given, I would say, and then of course our graphing calculator. So for those of you who are not yet familiar, the graphing calculator that we will be using for our class is desmos.com/practice. Okay, oops, sorry, my bad. I don't know what I did here. So what you need to do is go to your browser and then type in desmos.com, then you do the slash and then the word practice. Now there are three types of calculators. The most commonly used is the graphing calculator, because whatever you can do with the regular calculator or the scientific calculator, you can also do that with the graphing calculator. So simply select graphing calculator, okay? And then we start the practice. All right, so I can adjust here. Let me just zoom in a little bit more. Alrighty. Okay, so for us to be able to see the graph of this first set of data here, we need to put in the table into our graphing calculator. So how can we create a table? So please make sure that you are paying close attention to these steps, okay? So on your graphing calculator, you will see this plus sign here. So if you click on add item, click on table, all right? So by default, your table will include the X and Y value already. Now, as you can see from our given here, we are using the variables R and capital letter A. So just think of it, and typically with your table of values, the X values are always the left side of the table, and then the right side will always be the Y values. So we can input these points here. So you have 2 up to 10. So we can type it here. 2, 4, 6, 8, 10. Okay. Our Y values, a little bit tough to do. 12.57, 50.57, 27, 113.10, 201. 0.06, and then the other one is 314.16. okay, so how can you view your points? So we have already entered the data in here. You can close for the meantime. I can actually maximize this screen here so we can actually see. All right, So as you can see, you're not seeing the points here because if you're going to take a look, the y value is, the smallest y value is at 12. And as you can see here, your y value is at 5. So all you need to do is to zoom out. Okay, zoom out, and there's one point that we see there. There's another point that we are seeing here. Okay, and then there's that other point over there. So it pretty much looks like a line. But if you are going to analyze it very well, okay, hold on, let me just get this one up here. Sorry. So as you can see, it looks like it's a straight line, but you cannot always, like, depend on this right away, because if you're going to take a look, your values of y increases so drastic. All right, so we'll do a little bit of manipulation on our table here. So I'm gonna change the settings. Our y-axis, let's have it from so we start with 0, and let's say we end up until 350, and our how do you call this, our markers will be for every 50. Okay, something like that. Okay, so we can have it this way. So let's try to see here. And then our x-axis, let's adjust it also, since all of them are on one side only, from 1 up to 10. There we go. Oh yeah, we can do 20 probably. There we go. Okay, so now let's try to see. Okay, so we made some adjustments so that we can actually make those points closer to each other. So does this look like a straight line to you, or does it look like a curve? Okay, so based from our graph, those points are actually creating a curved graph. And so our first data set is non-linear. Okay, all right. So now let's see our second data set. We have the weight and the cost, and I have already taken the liberty of entering our data set. Now, looking closely at our graph, so we can zoom in, and as you can see, those points are perfectly aligned to each other. And so our second data set is a linear function. And like I said, if you would remember from the previous discussion, if there is a specific pattern, a consistent pattern that you are seeing here between your input and your output, then you will have a linear function. So take a look. This is a 0.8. It increased by 0.8 again to become 1.6, another 0.8. You get up 2.4. So it always increases by 0.8 on the y value, and your x values are always increasing by 2. So there's consistency on the increase on both the input and the output. Therefore, our function is a linear function. Okay, so why don't you try creating a table of creating a graph using this table of values and determine if this function is linear or not. Go ahead, try it out. So once you have entered the data set, your input and your output, and you take a look at your graph, you can see that those points are curving. They are not aligned perfectly to each other, and so this is a non-linear function. All right.